All right, so welcome to this webinar. Today, I'm Emma Gunnebrink and I'm the head of CX at Klang. And together with us today, we have Jakob Andersson, who is one of the co-founders and our head of AI here at Klang. And today, Jakob's gonna tell us about how we work with AI to make it understand local nuance and how it actually understands different dialects and languages. So welcome on board, Jacob. This is your first webinar.
Thank you. Sorry?
No, you can give a short presentation of yourself, so better than mine.
You touched on the main points. I'm one of the co-founders of Klang, and I also lead AI team. So programmer by trade, and I will sort of talk about how we use AI at Klang. If anyone have any questions during the talk, just feel free to interrupt or raise your hand and ask the question. Most of these slides I can talk probably for an hour or two, so feel free to ask questions. All we do at Klang is basically AI, at least from my perspective. We do a lot of taking cutting edge tech and trying to sort of bring it home and make it understand both Swedish and other Nordic languages, sort of the local nuances. And we try to do this in a very, very specific way where we can sort of bring it close to the customer. So really, Klang, sort of AI at Klang is more than a domain name. We sort of no part of the product would be possible without AI. So that's what we will talk about today. I assume most of or everyone here is familiar with Klang before, but sort of briefly, we are a secure note taker. So we focus on conversations, sensitive conversations, in highly regulated spaces, and that are very sensitive. So because of from that perspective, we need to do a lot on the AI side and also the product side to make that secure. The core product is sort of, at least from an AI perspective, a transcription part and analysis part, and both of those are AI powered. But the technology looks quite different from the transcription part and the analysis part. The transcription part is sort of powered by these speech tech models, while the analysis part is powered by large language models, which are fundamentally quite different. But we will be talking about both, mainly the transcription part, but we'll also touch on the large language model part in this little webinar. But briefly, we sort of first talk about the product, because that lens sort of reflects how we work with AI. Because it's so central, you can't sort of divide it from the product. You actually need to talk about the whole system in one. So sort of one of the core tenets of Klang is that sort of privacy comes first. It's not an afterthought. A lot of other companies sort of think about privacy in the 11th hour. And that's why you see a lot of opt-outs instead of opt-ins when you compare other AI products. Instead, at Klang, we sort of have this privacy and security mindset throughout the whole development process and how we set up the whole environments. And this also lends itself on how we talk about or how we build AI products. And because we sort of are really driven by this idea that sort of we want to meet the customer where they are and where their data are. And so we don't want the customer to do anything that they are not comfortable with their data. And then you need to build a really secure product. So from a product perspective, this sort of security and privacy mindset comes in many layers. You have sort of first fundamental layer, which is how we host the product. So our main cloud offering is hosted in the EU in a data center down in France. And that's where a majority of all our customers exist. And so we don't use American cloud providers like AWS. Instead, we rely on fully European cloud providers. And then if you have even more sensitive conversations, we also offer a isolated hosting option in Sweden. So then everything is hosted in Sweden on Swedish in a Swedish data center. So no information leaves the Swedish borders. And then if you have even further levels of security, we also offer like on-prem solutions. So we host it inside of the customer's own network. That's like the highest level of deployment security. So that's sort of the foundation. And then on top of that, of course, you have the product. There we do a lot on the architecture of the system. So we use throughout the system a lot of encryption, and all that encryption is user specific. So the different users have different sets of encryption keys. So you don't have one encryption key for all the data in the system. And then on top of that, like the architecture is built on something called zero trust. So basically, we don't trust ourselves, which might sound weird, but you can do that when you build computer systems to sort of add a further layer of security. And this sort of ensures that it's close to impossible for other customers to access other customers' data, and we can't access customer data. And it's then sort of a layer on top of that. There's like a compliance layer. So where we work with certification audits to make sure that we're not lying, we're actually doing this real. And then of course there's also some like principles like we don't use your data, like your data is your data, it's not our data just because it's in our system. So that's sort of all the privacy stuff on the product side. Then of course there are some principles and things that we need to do we in the AI team need to do. I think the main part in how you build privacy preserving AI is that you don't train on customer data. This is something a lot of customers, other companies do. And that's mainly because it's really nice to do that. In that a lot of what AI is about is sort of trying to capture and find the full distribution of data that's actually used in the system. And if you actually train on the data inside the system, you have the correct distribution. But we don't do this because it has some privacy implication if you do that, and we don't want to do that. And then sort of separate from not training on data is that we don't use customers' data for like building benchmarks and testing. This is something that's also quite common. So we actually have a very clear boundary between like the product and the development cycle, so that no customer data touches the development cycle, even when we're doing testing. And this way, we sort of all the development is completely isolated from the production system. This is a bit hard since like a lot of our customers' data distribution is not available on public internet, and since we only train on public data, it makes it quite a bit harder to find good high quality data. But this is just a challenge. Nothing that makes it impossible to build a company. So that's sort of the rough principles of Klang from a privacy standpoint. Then sort of what we inside of the AI team do is a lot of like taking global technologies and then bringing them locally. So trying to make them understand local context. So we leverage a lot of open source models, and then we sort of bring them home, as we like to say, home to Sweden, and try to make them understand like the Swedish language and the local context. Because sadly, there's like the general trend is that sort of global AI systems are English first AI systems. So this is quite a dense slide, but it highlights a lot of sort of the problems with modern AI systems, and it's that they are English first. So if you look at sort of transcription models, open source transcription models, they are trained on somewhere between 40 and 65% English only data. So the models themselves are trained on hundreds of different languages, but even then, like 65% of the data is in English. So if you take a look at the graph or the diagram on the left here, this is from the from a paper on the OpenAI Whisper model, which is a open source transcription model, and it's been like the workhorse of a lot of transcription systems out there, and it's actually the workhorse of our system. So we have fine-tuned a version of Whisper. And what this plot illustrates is sort of the training data distribution among the different languages. It's very important to note the log scale here. So on the y-axis, we have the word error rate. So that's how accurate the model is. So and please note that each step here is a 2x reduction in the error. So 80, 40, 20. And then on the x-axis, it's the amount of how many hours in the training data set for each language. And here it's also log scale, but each step is a 10x increase in the amount of data. So English sits down here in the lower quadrant, and it has by far the most data, so close to 600,000 hours. And then you can see Swedish sits here with some around 4,000 hours. And so important to note here that no other language is within 10% of the amount of training data that's available in English. And what also this plot shows is that the more data you have, the better the model. So English is down here at under 5% error rate, while Swedish sits at about 1,000 hours with a lot higher error rate, close to 10%. So what this really illustrates is that the more data you have, the better the model. And sadly, a lot of the data that models are trained on is in English. And I mean, this is fairly natural, given that most AI companies are based in the United States. So they obviously focus on English. But it is like a true problem if you want this type of technology to be deployed widely. But this graph is more than just like a cool graph with a nice scaling curve on it. This is from like our perspective, actually a roadmap. So a lot of what we do here at Klang is trying to traverse this line. So you can see a trend line here, which sort of plots the hours against word error rate. And what we try to do is take Swedish and move, trying to move along the trend line, and by gathering more data, and thus achieving a lower error rate. So our fine-tuned model is, I believe, around 5% word error rate. So we have collected tens of thousands of additional training data hours, and that we achieved a lower error rate. But it's not really just about sort of gathering more data, even though we like to say that data is king. All data is not king. What you want is more good quality data, and what high quality data means is that it's very varied. So what you want to do is capture the full distribution. So from our perspective, of course, we want to capture all the dialects, because we sit in Helsingborg, we speak almost Danish, if you ask some people. So you want to capture all the dialects in Sweden, and of course in all other countries. And then you also want to capture other distributions in humans. So of course genders. So you don't want only male data. You want all genders represented. And then you want all the different types of conversations, of course, people in specific industries speak in a very specific way. You want to capture that distribution as well. And then on top of that, you also want to capture all the different settings that the conversation might take place in. So cafes, for example, or different types of audio environments. The messier, the better, and the wider range, the better. So this is where we spend probably 90% of our time. And we spend very little time on sort of the model training aspect. Those techniques are very well known. The data gathering, however, is not. And of course, we we gather all this data from publicly available sources, which makes it hard to capture, but it's the way, so the challenge we have taken upon ourselves. Yeah, and then of course, like we also deploy this model in the real world. We just don't run like a little daycare center for researchers. We actually have customers. We actually have usage, and that sort of means that you need to take a wider approach to this whole problem, because like the real world is very, very messy, and that's a very common fault as well. It has gotten better in the research over the years, but like early research in this field was all on like really nice, clean data, and then it's easier to get very good results. However, in the real world, you have a very messy set of inputs. So, for example, you have bad audio. People have a tendency to not use good mics. And then if you're recording meetings, if there's meetings with a lot of people in it, people are talking over each other. And then, of course, like multiple accents. And something that's quite new, since sort of digital meetings becoming more common, is that a single file can have many different audio environments, because each speaker inside of a meeting being completely different places. You might have one speaker that's sitting in a cafe, one is sitting in a really nice conference room, and one is like in an aquarium or something with a lot of echo. And sort of, so in some sense, because of digital meetings, everything has become more complex from an audio standpoint. So if we look at Klang, this is sort of the main transcription view. I think most of you have seen this. And it might look very simple from a user perspective. Here we can see you have the speakers, you have the audio, what each speaker said in the file. But for us to be able to build, sort of render this page, we're actually running 5 different models to be able to do this with high quality. So the pipeline inside of Klang, something like this. After the user uploads the file or records the file, we start with cleaning up the audio. So we try to separate out the vocal track from the file. So trying to remove all the background noises. If someone's playing music in the background, we try to delete the music and only have the speech left. That way we have a much cleaner file. And then we take that file and we try to detect where in the file people are speaking. Sometimes people upload completely silent files for us, then we don't need to do a whole lot. And sometimes the speech might be very sporadic. And what this also allows us is that if people are speaking with long pauses, we can actually do some optimization and process this file in parallel, which is very nice. Then it means a quicker delivery for the customer. Once we have detected where people are speaking, we can actually detect the spoken language. So we don't know beforehand what language people will be speaking in inside of the file. And actually, since we have some of our customers are using interpreters, there might be multiple languages present in the file. So what we want to do then is have a really dense representation of where people are speaking and what language people are speaking for like each second inside of the file. And then once we know that, which language people are speaking, we can try and transcribe the audio in the correct language. So in the interpreter case, we want to transcribe in the same language as people are speaking. So if someone's speaking, let's say a German interpreter, we want German when people are speaking German, and like Swedish when people are speaking Swedish. So once we know the spoken language, it's only then that we can actually start transcribing the file. And then we leverage sort of the transcription model. And then after we transcribe the file, we also detect the speakers. So we say, speaker 1 here, speaker 2 here, speaker 3 here, and then we can sync that up with the text. And then only then can you render this full page. So there's a lot of complexity going on behind the scenes to make this happen, and we do this, to have a highly accurate transcription and sort of tame the beast that is reality, make it work. So that's sort of the transcription side of the house. Then we have the LLM side of the house. Here we do like a whole different set of techniques and a whole different sort of approach to how we build AI systems. We completely different from the transcription part. But if we just start with looking at the system, this is probably a view most people have seen inside the system. This is sort of like the overview of a notebook or sort of an atlas. And there's very little like screen real estate of this that's would be possible to render without an LLM. So sort of it starts with the tag over here. So for all the files that are uploaded to Klang, we try to categorize them based on the type of conversation. So in this case, this is a sort of a test file for of a research conversation. So we give that the tag interview/research. And then once we know that tag, we can generate a specific overview of the file here. And sort of the tag we have different tags for like stand-ups and other types of meetings. And all of that is LLM powered. And then on the right here, of course, you have the AI agent or the chat. And that's, of course, using the LLM. And then you can also run flows, which is sort of like predetermined workflows. And all of those are also like heavily powered by LLMs. For example, if you want to summarize a conversation and send it to Slack or put it inside of a CRM, all of that is powered by LLM. So really, like a lot, you can't render this view without an LLM. However, LLM have their own like unique challenges. Of course, they are incredibly expensive to train, and they're sort of evolving very, very rapidly. So from our perspective, there's no need to do, or it's not economically feasible to do any type of training. Other people are building large data centers to do that type of training. We don't have that type of money. But that doesn't mean that we can't do a lot. Just that we need to rely on a different set of techniques. So we rely heavily on something called in-context learning, which is just like a fancy way of saying, if you give LLMs enough context and relevant context, you can sort of make them highly proficient on your data without actually training on the data. And how you do that is that you build tooling so that the LLM can sort of get enriched with relevant context of the data. And here, there's been a large shift over the last couple of years. So 2 or 3 years ago, what was sort of in fashion and what we were using in sort of an old version of Klang was something called retrieval augmented generation. And what it is basically, it's just also like a fancy word of that you take the user query, so what they type into the chat box, you convert that into a vector, and then you search against all of their content, and then you take the most relevant documents and you just dump that into context, and then you give the LLM the query, and you let the LLM answer it. This works fairly well, but it has a lot of limitations. But that sort of was the only way to do it 2-3 years ago. What has happened since is something called tool calling, which is a way to give the LLMs tools that they can use them, decide when to use themselves, instead of always doing this regular search-based approach. Because the user might actually just type in a query that you don't need to do any search for, that the model can just answer themselves. So we have shifted to the tool calling approach. So now we have a tool that allows the LLM or the model to read a document, and it can decide which documents to read inside of the atlas. And that way it can sort of find relevant context for the specific query. And then sort of a separate challenge for us when it comes to LLMs is actually serving these at scale. So since we have all of these isolated deployments, we need to serve a local LLM inside of those data centers. And that's quite hard in Sweden, since that infrastructure is quite poorly built out. But that's sort of a separate challenge from like training and making good use of these models. But these AI systems require a very new safety approach. So from a high level perspective, what it means to build really powerful AI systems is giving up more of the system control to the model and letting the model decide itself. And that's quite the large change. Like from our perspective, we actually moved from building deterministic software to building highly probabilistic software. And the industry at large is still sort of grappling with that idea and how to do that safely and securely. What we have come down to at Klang is sort of what this is all about, is building a really, really good sandbox around the model, so that we are resilient to a lot of attacks. Because the sort of a downside of how you design this system is that the main threat vector is also the main use case vector, which is quite different from traditional software. So that text box is the main threat vector, but you can't close down that threat vector because that's where all the value comes from as well. And sort of the threat vector is something called prompt injection, because you let the user just write whatever he wants. If they write a prompt that breaks the model, if you have a poorly designed system, that might make the model leak user data, and that's something that sort of you want to avoid at all costs. And here I'm actually really happy that sort of Klang has had this like security focus from the start, because it meant that we built a system that has a really strong secure foundation, and then it was really easy to integrate tool calling in a safe and sort of safe approach. So because like everything is encrypted with user-specific keys, the model can't read any other data than for the user that asks the question, and then sort of. So that sort of at the base layer provides a lot of security, and then of course you build a lot of checks on top of that. But what we try to do is sort of go through each part of the system and say, okay, if this breaks, do you have anything else that catches us? And having strong encryption at the bottom is really nice. But of course, like nothing replaces testing. So it's like test. It's the holy rule of product development, and it's more true now than ever. Like only the paranoid survive. And so we spend a lot of time during the development cycle to try and just break this system and sort of push it over the edge and see how it behaves. And sort of then, if it behaves badly, we build remedies for that. So just test. So if there's anything you should take away from this session, it's collect good data and test a lot. Yeah, that's it for me. That's sort of a quick overview of how we're working with AI here at Klang.
Cool. Do we have any questions within the audience? And we have someone joining directly. Okay, welcome in. Joachim, we just ended up with some questions regarding how we work with AI and how we train our models. And as you heard, we have quite a few layers of security to actually keep everything safe for you as user. So if you have any questions, go ahead, just raise your hand. If not, we will send this out. We will put it up on YouTube so you can see it again, share it with friends. Do you have any other questions, you can reach out directly to Jacob as well. You see his email here in the presentation. We have questions here.
We have a small API offering mainly for transcription, but that's sort of available upon request. But yes, you can. So the transcription part you can use. The sort of LLM and analysis parts you can't.
Great. Thumbs up. All right. With that said, I think we will end for today. But feel free to reach out. You can also reach out on LinkedIn to both me and Jacob. You find our LinkedIn. Yeah, just email or keep an eye on Klang. Follow us on Instagram. You can always also follow us on Instagram, but follow us on LinkedIn to find out more. We will share more webinars specific on how to use the product, and yeah, more to come. All right, thanks so much for joining.
Thanks, everyone.